Friends, welcome to my channel. Dhanesh here.
This is the summary of the video. After watching the video, you will get the complete picture of the implementation for sentiment analysis for Twitter data, random forest algorithm and implementation, TF-IDF vectorizer and implementation, bag of words model and implementation, and how to make predictions and evaluating the model.
Random forest is a supervised learning algorithm. It can be used both for classification and regression problems. But however, it's mainly used for classification problems. A forest is comprised of trees. It is said that the more trees it has, the more robust a forest is. Random forest creates decision trees on randomly selected data samples, gets prediction from each tree, and selects the best solution by means of voting. So that's what random forests do. Let's get deeper into the random forest. See, before getting into a random forest, in depth, I am giving to I am going to give some idea on decision tree. See, a decision tree, you may be familiar, is a flowchart like structure in which each internal node represents a test on an attribute. Example, whether a coin flip comes up heads or tails. Each branch represents the outcome of the test, and each leaf node represents a class label. That means the decision taken after computing all attributes. That's a decision tree. Now we will get into the random forest in depth. When we compare a random forest versus a decision tree, say what's the difference between random forest and a decision tree? This is the pictorial representation of a random forest. Here I am comparing a simple decision tree with a random forest. Random forest is a set of multiple decision trees. Deep decision trees may suffer from overfitting, but random forest prevents overfitting by creating trees on random subsets. Decision trees are computationally faster. Random forest is difficult to interpret, while a decision tree is easily interpretable and can be converted to rules.
So different feature extraction methods we usually do are the bag of words model, bag of n-gram model, TF-IDF model, word to vec, word embedding, or vectorization. These are all the steps we usually follow. We are going to discuss about bag of words model. The bag of words model is simple to understand and implement. It is a way of extracting features from the text for use in machine learning algorithms. It has seen great success in problems such as NLP, natural language processing, information retrieval from documents, and document classifications. This is the pictorial representation of the different steps in bag of words. Input text, first we do clean the text, then we tokenize. Word tokenization, there is a separate video on word tokenization by using NLTK, and even by using Keras. We have separate videos, you can watch that. After tokenization, we build the vocabulary. After that, we generate the vectors. These vectors are the input to the machine learning algorithms. Let's discuss how it's happening, how it's working. Bag of words. Here we use the tokenized words for each observation and find out the frequency of each token. Frequency is the number of repetitions. Here, how many times a word is repeating, that is frequency. See, let's take an example. It was the best of times, it was the worst of times, it was the age of wisdom, it was the age of foolishness. So these four sentences, let's take. We treat each sentence as a separate document and we make a list of all words from all the four documents, excluding the punctuation we get. Let us assume that each sentence is a document and we are creating the words, and we are excluding the punctuations and all these things. We know how to do it because we can watch the stop words, the removal, all these things we discussed. You can watch those videos. So we get it was the best of times, worst, age, wisdom, foolishness. These are all the words coming in the above sentences. The next step is to create the vectors. Vectors convert text that can be used by the machine learning algorithm. We take the first document, again, it was the best of times, and we check the frequency of words from the 10 unique words. We have taken 10 unique words above. And bag of words model. See, in the bag of words model, we have taken it's equal to 1, was, it's 1, the, 1, best is equal to 1, of is equal to 1, times is equal to 1. So all those things in this first sentence it's present, but worst it's not there, 0. Age it's 0, wisdom it's 0, foolishness is 0. When we consider the first statement, sentence, this is the model we get. See, like this, the rest of the documents will be, it was the best of times, we can get it like, it was the worst of times, we can write it as 1, 1, 1, 0, 1, 1, 1, 0, 0, 0. It was the age of wisdom, in the same way we can write it as 1, 1, 1, 0, 1, 0, 0, 1, 1, 0. It was the age of foolishness. Again, 1, 1, 1. The next word in the vector is not there, so we are taking it as 0. See, here we are taking it as 1, 1, 1. So if this word is not there, we will take it as 0 there. So like that. It was the age of foolishness. Again, 1, 1, 1, 0, 1, 0, 0, 1, 0, 1. In this approach, each word or token is called a gram. Creating a vocabulary of two word pairs is called bigram model. For example, the bigrams in the first document, it was the best of times, are as follows. It was, if you are considering two words, bigrams, it was the best, best of times. Like that, you will get it. Another thing you need to understand here is the vectorization. The process of converting NLP text into numbers is called vectorization. In machine learning, different ways to convert text into vectors are counting the number of times each word appears in a document, calculating the frequency that each word appears in a document out of all the words in the document. A bag of words implementation, you have different types of implementation: count vectorizer, TF-IDF vectorizer, and grams. This is the steps we follow you during feature extraction. The input, it is the text. You will clean the text, then you will tokenize. You will apply, word tokenization, lemmatization, stemming. Then you will build the vocabulary. Then you will generate vectors. These vectors are the input to the machine learning algorithm. This is very important. So this is the, pictorial representation of the feature extraction. You can easily understand this. Then what is this TF-IDF algorithm? We call it as word frequency algorithm as well. TF-IDF algorithm or word frequency algorithm. TF-IDF stands for term frequency inverse document frequency. This is a technique to quantify a word in documents. We generally compute a weight to each word which signifies the importance of the word in the document and corpus. This method is widely used. It is a widely used technique in information retrieval and text mining. And it is easy for us to understand the sentence as we know the semantics of the words and the sentence. The computer can understand any data only in the form of numerical value. So for this reason, we vectorize all of the text so that the computer can understand the text better. Now we will see these are all the terms this is the math of TF-IDF. See, TF-IDF, that is equal to, this is the equation you need to understand. TF-IDF is equal to term frequency into inverse document frequency. Term frequency is TF. I will tell you what is term frequency. We will be discussing what is inverse document frequency. IDF we are going to discuss. See, T, the letters we are using, T means term or a word, term or word. D means document or set of words. N means count of corpus, and corpus means the total document set. These are all the letters we use in the coming discussion. So the TF-IDF, the formula for TF-IDF is the term frequency into inverse document frequency, IDF. Let's get into try to understand term frequency. This is very simple. See, this measures the frequency of a word in a document. Term frequency measures the frequency of a word in a document. When we are vectorizing the documents, we check for each word's count. In worst case, if the terms doesn't exist in the document, then that particular TF value will be 0, and in other extreme case, if all the words in the document are same, then it will be 1. The final value of the normalized TF value will be in the range of 0 to 1. Now, term frequency TF is how often a word appears. See, in the simplest way, we can define term frequency TF is how often a word appears in a document divided by how many words there are. For example, the formula for term frequency is number of times term or word T appears in the document, the whole divided by total number of terms in the document. For example, you have a document with 1,000 words in that document, and you want to find out the term frequency of the word, pen. You want to find out the term frequency of the word pen. So pen is repeated how many times in the document? Let us assume that it is repeated 10 times. If it is repeated 10 times, how do you calculate? It is 10 divided by 1,000. It is 10 divided by 1,000 is the answer. See, what is 10 here? For example, you are calculating the term frequency of the word pen. This is the word P-E-N. The term frequency of the word pen in the document. The word pen repeats 10 times. Number of times the word pen comes in the document is 10. The total number of terms in the document is 1,000. Then what is the term frequency? It is 1. This is equal to 1 by 100. This is the way you calculate it. This is term frequency. Now I will discuss document frequency. This is rarely you use, and I will explain what is document frequency as well. This measures the importance of document in whole set of corpus. This is very similar to the term frequency. The only difference is that TF is frequency counter for a term T in a document D, whereas DF, document frequency, is the count of occurrence of term T in the document set N. That means DF is the number of documents in which the word is present. So that is another term you will use in this algorithm, that is document frequency. See, another important point, this is really important, you need to understand here is the inverse document frequency. See, what is inverse document frequency? See, we already discussed term frequency is how common a word is, how common the word appears in a document, that is term frequency. Inverse document frequency, IDF, is how unique or rare a word is, that is inverse document frequency. The equation for inverse document frequency is logarithm of total number of documents, the whole divided by number of documents with term T in it. That is the formula. See, you have the log of total number of documents. See, logarithm of, it's a log to the base e, it is not underscore, it is log to the, sorry, it is the formula is log to the base e. Here, then total number of documents divided by the number of documents with term T in it. This is the inverse document frequency. For example, if you have 10 documents, see, you have the total number of documents with you is 10. This is 10. Number of documents with term T in it will be, you can see, let us assume, more easier way. I will, then it would be more. See, let's assume that we have 1000 documents. The number of documents with term T in it is, we have only 10. So you will take logarithm of 1000 divided by 10. Logarithm of 1000 divided by 10. See, what is logarithm of 1000 by 10? That is log of 1000 by 10 is 100. Right? What is logarithm of 100? It is 2. So 2 is the, you can take it as the inverse document frequency. Inverse document frequency is how unique or rare the word is. I will do a sentiment analysis using Twitter data, using the scikit-learn library, random forest algorithm, and TF-IDF algorithm. Sentiment analysis refers to analyzing an opinion or feeling about something using data like text or images regarding almost anything. Sentiment analysis helps companies in their decision-making process. For instance, if public sentiment towards a product is not so good, a company may try to modify the product or stop the production altogether in order to avoid any losses. There are many sources of public sentiment, example, public interviews, opinion polls, surveys, etc. However, with more and more people joining social media platforms, websites like Facebook and Twitter can be parsed for public sentiment. So in this video, we will see how we can perform sentiment analysis of text data. Here it's given tweets about 6 US airlines. The task is to predict whether A tweet contains positive, negative, or neutral sentiment about the airline. This is a typical supervised learning task where a given text string we have to categorize the text string into predefined categories. To solve this problem, we will follow the typical machine learning pipeline. We will first import the required libraries and the dataset. We will then do exploratory data analysis to see if we can find any trends in the dataset. Next, we will perform text pre-processing to convert textual data to numeric data that can be used by machine learning algorithms. Finally, we will use machine learning algorithms to train and test our sentiment analysis models. Uh, the first step, as always, is to import the required libraries. Let me, yeah, it's fine, it's working. The data set that we are going to use for this implementation is uh, it's freely available in the GitHub link. To import the data set, I will use the pandas read underscore CSV function. Yeah, it's done. So I have used the head method to see the output from the data set. You can see it here. To explore the data set a bit to see if we can find any trends. Before that, we will change the default plot size to have a better view of the plots. Let me execute the script. Let's first see the number of tweets for each airline. We will plot a pie chart for that. Let me run this. Yeah. In the output, you can see the percentage of public tweets for each airline. United Airlines has the highest number of tweets, that is 26 percentage, followed by US Airways, that is 20 percentage. Let's now see the distribution of sentiments across all the tweets. Let's execute them. So the output looks like this. From the output, you can see that the majority of the tweets are negative, 63%, followed by neutral tweets, 21%, and then positive tweets around 16%. Now, let's see the distribution of sentiment for each individual airline. The output look like this. It is evident from the output that for almost all the airlines, the majority of the tweets are negative, followed by neutral and positive tweets. Virgin America is probably the only airline where the ratio of the three sentiments is somewhat similar. Let's use the Seaborn library to view the average confidence level for the tweets belonging to three sentiment categories. Let's execute the script for that. The output look like this. From the output, you can see that the confidence level for negative tweets is higher compared to positive and neutral tweets. If- Enough of the exploratory data analysis. Our next step is to perform some processing on the data and then convert numeric data into text data. Tweets contains many slang words and punctuation marks. Here we have to do the data cleaning. We need to clean our tweets before they can be used for training the machine learning model. However, before cleaning the tweets, let's divide our dataset into features and label sets. Our features, our feature set will consist of tweets only. If we look at our dataset, the 11th column contains the tweet text. Note that the index of the column will be 10 since pandas column follows zero-based indexing scheme where the first column is called the zeroth column. Our label set will consist of the sentiment of the tweet that we have to predict. The sentiment of the tweet is in the second column, that is index 1. To create a feature and a label set, we can use the iloc method of the pandas data frame. Let's do the script for that. Once we divide the data into features and training set, we can process data in order to clean it. To do so, we will use regular expressions. In the script, we start by removing all the special characters from the tweets, the regular expressions, re.sub does that. Next, we remove all the single characters left as a result of removing the special character using the re.sub regular expression. For instance, if we remove special character from jacks and replace it with space, we are left with jack s. Here s has no meaning, so we remove it by replacing all single characters with a space. However, if we replace all single characters with space, multiple spaces are created. Therefore, we replace all the multiple spaces with single spaces using re.sub method in regular expression. Furthermore, if your text string is in bytes format, a character B is appended with the string. The above script removes that using the regular expression. Finally, the text is converted into lowercase using the lower function. Let me run this. Yeah. Next is representing text in numeric form. Statistical algorithms use mathematics to train machine learning models. However, mathematics only work with numbers. To make statistical algorithms work with text, we first have to convert text to numbers. To do so, three main approaches exist: bag of words, TF-IDF, and word to vec. In this video, I will be using the bag of words and TF-IDF. Scikit-learn library contains the TF-IDF-vectorizer class that can be used to convert text features into TF-IDF feature vectors. Script, we define that the max underscore features should be 2500, which means that it only uses the 2500 most frequently occurring words to create a bag of words feature vector. Words that occur less frequently are not very useful for classification. Similarly, max underscore df specifies that only use those words that occur in a minimum of 80% of the documents. Words that occur in all documents are too common and are not very useful for classifications. Similarly, min-df is set to 7, which shows that include words that occur in at least 7 documents. It's working. Next is dividing data into training and test sets. So here in the previous script, we converted the data into numeric form. As the last step before we train our algorithm, we need to divide our data into training and testing sets. The training set will be used to train the algorithm, while the test set will be used to evaluate the performance of the machine learning model. Let's do that. We use the train underscore test underscore split class from Sklearn model selection module to divide our data into training and testing set. The method takes the feature set as the method takes the feature set as the first parameter, the label set as the second parameter, and a value for the test underscore size parameter. We specified a value of 0.2 for test underscore size, which means that our data set will be split into two sets, 80% and 20% data. We will use 80% data set for training and 20% data set for testing. Next is training the model. Once the data is split into training and test set, machine learning algorithms can be used to learn from the training data. You can use many machine learning algorithms. However, here we will use the random forest algorithm owing to its ability to act upon non-normalized data. The sklearn.ensemble module contains the random forest classifier class that can be used to train the machine learning model using the random forest algorithm. To do so, we need to call the fit method on the random forest classifier class and pass it our training features and labels as parameters. Let's write the script. Making predictions. Next is making predictions and evaluating the model. Once the model has been trained, the last step is to make predictions on the model. To do that, we need to call the predict method on the object of the random forest classifier class that we used for training. Let's write that script. It's working. Finally, to evaluate the performance of the machine learning model, we can use classification metrics such as confusion metrics, FN score, accuracy, etc. To find the values for these metrics, we can use classification underscore report, confusion underscore metrics, and accuracy underscore score utilities from the sklearn metrics library. Let's write the script. The output of the script looks like this. See, from the output, you can see that our algorithm achieved an accuracy of, it's around 75, 70 to 75% each. And you can see the precision, recall, FN score. This is an exercise for you. You can use some other machine learning algorithms such as logistic regression, support vector machine, or k nearest neighbors or KNN and see if you can get better results instead of random forest.
Thanks for watching. Please like, share and subscribe. Thanks a lot.